Hello everyone, welcome to the classes of calculus. Today we are going to dive into the different kinds of functions, especially focusing on one-to-one, many-to-one, one-to, and bijective function. Let's begin with one-to-one. This function is also known as injective function. A function fx is one-to-one if every element in the domain maps to a unique element in the range. In other words, no two different inputs produces the same output. And in this condition, the function will be an one-to-one function. For example, we have this function fx equal to 2x. We have fx equal to 2x. We have input values in the domain are this. If we have x equal to 1 as input values, we have output values f of 1 equal to 2. See here, this is 2. And similarly, we have f of 2, it will be 4. And f of minus 3, it will be minus 6. So here you can observe that no two different input, see here, no two different input produces same output. So it is a one-one function. Now let's look at the many-one function. In this type of function, multiple elements in the domain can map to the same element in the range. Multiple elements in the domain can map to the same element in the range. In other words, different input can produce same output. For example, we have the function fx equal to x square. So we have input values x equal to 1, and we can write our output value f of 1 is equal to also 1. And for x equal to minus 1, for f of minus 1 is also 1. So see here, you have different input values and you got the same output values. This kind of functions will be many-one functions. So many-one functions have different input, but it can produce same output. Next, let's discuss the onto function, which is also known as the surjective function. A function fx is onto function if every element in the codomain, you see here, this is codomain, every element of the codomain is the images, you can call it pre-images of some elements or at least one elements from the domain. This means function covers the entire range. In that case, it will be an onto function. So if you take an example, you see here, you have fx equal to 3x. And your input values are 1, minus 1 and 3. So f of 1 will be your output value and it will be 3. F of minus 1, it will be minus 3. And f of 3, it will be 9. So see here, your input value covers the entire range. You see here, no element in the codomain is left out. This type of function is onto function. Now let's talk about one onto function. This is also called bisective. Bisective. A bisective function is combination of two functions, one and onto. This means that every element in the domain maps to a unique element in the codomain, and every element in the codomain is covered. Let us see some real life example of these functions. First of all, one injective function. Suppose in a school, each student is given unique ID number. So no two students have same ID numbers. If fx is the function of ID number two students, then the function is one-to-one because no two students share same ID number. So you can call this function as one inject function. Now in the second case, different address in the same area will have one pin code only. Different address in the same area will have one pin code only. If fx represents the function, assign a postal code, to addresses. Then it is a many-one function because many addresses have one postal code. So it is many-one. Go to the next function. Suppose a company distributes a new product, ensuring that every customer on their list gets at least one product. If fx represents the function where x is the customer and fx is the product, then the function x is the customer and x is the product. Then it is a onto function because every customer received one product, means the function covered the entire codomain. So it is a onto function. And for one onto function or bijective function, suppose in a school each student assigned exactly one locker, and each locker assigned exactly one students. So if fx represent the function that assigned a locker to student, then it is a bijective because no student can share locker and no locker will left unassigned. So in this condition, this is onto function. So these are some real life examples. We can relate all these examples with the conditions and definitions of all these functions, and it will be more clear to you next time. Thank you for watching. If you have any questions, feel to ask in the comments. Keep practicing, and I will see you in the next lecture. Thank you.